All right, so picking up where we left off on Monday, we were looking at an example where we were staying in a hotel some distance from a monument. If I stood at my window, looked straight out, and then tilted my head up 18 degrees, I saw the top of the monument. If I stood at my window, looked straight out, and then tilted my head down 3 degrees, I could see the bottom of the monument. And we used that information to build two right triangles. And we use the fact that that monument is known to be 400 feet tall to write the opposite sides of those right triangles in terms of 400 and that unknown x, which is the vertical side of the smaller triangle. We know we want, ultimately, the distance that the hotel is from the monument. We want d. And so we set up tangent ratios for both triangles. So for the top triangle, where this distance is 400 minus x, we had tangent of 18 is 400 minus x over d. For the bottom triangle, we had tangent of 3 is x over d. And ultimately, I want d. So I'm going to take the second tangent function and solve it for x. And then I'm going to substitute it into the first fraction. So over here on the right, we have tangent of 3 equals x over d. I want to solve for x. I want to get x by itself. What should I do? Multiply, yeah. Times d so that those guys cancel. So we get x equals d tan 3 degrees. And I agree, that's correct. And I am going to take that, and I am going to plug that in to my other tangent expression. So where I had x before, now I'm going to have d tan 3. So tan 18 equals 400 minus d tan 3 over d. And I am absolutely certain we are going I, as a mathematician, do not like fractions. What could I do to get rid of that fraction? Multiply. Same thing we did before. Let's multiply both sides by d. So that those guys cancel. It doesn't look pretty, but if I can convince my brain that tan 18 and tan 3 are just numbers, which they are, this is a linear equation in D, just like you saw in Math 1 and Math 2. And if I want to solve for D, the first thing I need to do is get all of the D's on the same side of the equation. How can I do that? Add. Yeah, there's this being subtracted. Let's add it to both sides. Plus d tan 3 plus d tan 3. So we get d tan 18 plus d tan 3 equals 400. I see on the left something that both terms have in common. What do they have in common? A d. Let's pull a d out in front. Let's factor a d out. What am I left with? Tan. I'm left with those tan expressions. Tan 18 plus tan 3. Yeah. And remember, this is multiplication between the d and the thing in parentheses. I want d by itself. How do I undo multiplication? Division, yeah. Bless you. I am going to divide both sides by that thing in parentheses. On the left, that makes me a happy mathematician, because all I am left with is D. Yeah. On the right, I am left with a fraction that looks gross. 400 on top, tan 18 plus tan 3 on bottom. Looks gross. What can I do with that expression on the right? Shove it in your calculator. That is calculator math right there, my friends. Calculator math. Reminders. 2 of them. What mode should your calculator be in? Degree is very good. The denominator has an expression, parentheses around the denominator on your calculator. I am going to give you a second to do that while I also do that. I am assuming that you guys will be faster than me because I need to set up my calculator. It's a fancy calculator. So 400 divided by tangent of 18 plus tangent of 3, yes? Ooh. Whoops. So first question, is anybody else getting the same number that I am getting? Good. That is a good sign. If you didn't, first 2 things to check, is my calculator in degree mode? Did I put parentheses around the denominator of my fraction? Because if you missed one of those things, you're going to get the wrong answer. Second question, what are the units on that answer? Same units the other distances were in, feet. There's a 400-foot tall monument. I must be about 1,060 feet from the monument when I look up and down, which explains, since I'm so far from the monument, I don't have to tilt my head very far up or very far down to see the top and bottom, because I'm so far away. Okay, things to note about that example. First, we know how to set up trig ratios. Second, we know how to solve linear equations for a missing variable. Those are skills that we've had since Math 1 and Math 2. What's new is that we're now carrying around expressions instead of numbers. We're not plugging values in our calculator and carrying around rounded decimals. We are carrying those trig functions around all the way to the bottom of the expression. And it's going to feel awkward for a while you practice it, but that is a useful skill for college math. So while you are doing these types of problems, don't plug them in your calculator until you get to the last step. Carry those trig functions around just like you would any other number. Yeah? Good practice for you. Good. Questions on how we tackled it? Are we sure? No one has any questions? Not a single question. Some of you are giving me the dead fish stare, so there must be some questions percolating in there somewhere. You can ask. You should ask. There's something percolating. You should ask. Oh, so here, so what I noticed at that stage, because I added this to get the D's on the same side. I noticed that both of these terms here had a D in common, and I factored it out in front, which sits here. And then the leftovers end up in parentheses. Just like if I had 2x plus 5xy, I see an x in common. I can write that as x 2 plus 5y. It's that same idea. Yeah, that was a good question. Other questions? Okay, I'm going to stop our video and then we're going to move on to our next activity for the day.